All right, folks, I'm ready to get started. Welcome back, everyone. Welcome back to the third week of class. I hope everybody had a good weekend. I hope things are going well as far as your other classes and you kind of organizing your life to make all of this work out. Are there any questions anyone would like me to address before I get moving with today's material? All right, great. So we are moving along here. We covered the first two chapters already. We're going to cover chapter 3 this week. And chapter 3 deals with quantitative demand analysis. So last week we looked at qualitative demand analysis, where we just kind of looked at the nature of supply, the nature of demand, the interaction, the equilibrium price and quantity that they set. What happens when either side changes? What are the things that change either supply or demand? What kind of effect they have on price and quantity as far as like it going up or down, or maybe it being unclear. So that's us describing sort of the qualities of the market. And now we're going to look at the quantitative demand analysis, where we go from the theoretical to the more practical, and we bridge it with the tools that we use to bridge it, which is statistics. So we'll look at a couple of characteristics of quantitative demand analysis that are useful for management, specifically different types of elasticities. And then we will, on Thursday, handle the statistical part of the chapter. So I'll first introduce the elasticity concept, and then we'll talk specifically about the own price elasticity of demand. So measures of elasticity are basically measures of sensitivity of one variable to another variable. So the own price elasticity of demand is the measure that kind of tells us, well, how responsive, how sensitive are people in a particular market to changes in price? Are they very sensitive, so they'll change their quantity demanded a lot when small changes in price occur, or are they unresponsive, and therefore even if changes in price occur, it has very little effect on the amount that people are willing to buy in the market. So that's what this measure tells us, and so we'll look at the mathematics of it, and then ultimately we'll look at how we can actually get this information from data we have about a particular market that we might be operating in. Another elasticity is the cross-price elasticity of demand. So how sensitive is the quantity demanded of one good to changes in the price of another good, like a related good, right? Like a substitute or a complement. So we'll talk about that. And then finally, we'll look at income elasticity of demand. How sensitive are changes in quantity demand to changes in income in a particular person or a particular population that might be of relevance to you, me, us, whomever. And then, so that's what we'll cover today, and then we'll jump into the statistical stuff on Thursday. Just to keep in mind, the first exam will be 2 weeks from today. So we cover chapter 3 this week, we cover chapter 4 next week, and then the first exam covers chapters 1 through 4. So it's not immediately going to happen. We've only been together 2 weeks, so we still have that much time again. But time does tend to move forward at a pace that maybe we are not completely comfortable with. Sometimes we are, sometimes we aren't. And so it's coming. So it's just keep it in mind. It also the chapter 4 stuff is a little bit more sort of abstract. It's the rational consumer choice model, where you look at the decision to consume by an individual, and we use budget constraints and indifference curves to sort of analyze that decision. I don't know if you've been introduced to these concepts before. I know I do introduce them in my introductory micro course, but nonetheless, they are a bit more abstract than your standard like demand supply stuff. So if you want, and if you have some time, I would suggest to kind of just get ahead. And I do have my if you just click onto my YouTube channel from those links on Moodle, you can look at playlists on my channel, and there's playlists from my lectures from last year, from last semester, for this class. So you could get ahead even on the lectures if you want, if you don't want to do the reading on your own, whatever. However you choose to do it, there are options for you. I do suggest you do that because, again, the first exam will be 2 weeks from today, so we'll cover that next chapter next week, and then you'll have to learn that stuff on top of reviewing everything you've already done. So it's good to always know what's coming, assess how much time you have, and then just kind of make a plan for yourself to make it all work out for you. Obviously, beyond these responsibilities in this class, you have other responsibilities as well. So it's good. It's just good when you have a lot of stuff that's piling up on you, or that there are there are going to be moments where you're going to require to spend more time learning certain things versus others, to kind of parse out your time the right way beforehand, before it all kind of hits the fan, and then you're just you're just doing what you can, and ultimately the result is uncertain. Versus if you start now, you'll feel more confident, more comfortable, and the result will be better. So I hope your mind is in this already, because it should be. And then second, you are thinking about it all the time. Like, how can I make it work the best? What's going on in my life? How can I organize things to make this work out? Because again, this should be the thing that you do, and then everything else should be things that you do when you're not doing this. And if you're not doing that, then you're not taking the right approach here, because this should be a priority. Sometimes people tend to kind of put this to the side, or make this not as important as the other things, and you did choose to do this. Like, this is something you signed up for. So if you sign up for it, you have to be realistic about what it requires of you, and what it requires of you is to have that sort of all-encompassing mentality at all times, with respect to everything that needs to be done in a given semester, and how you're going to best get that accomplished. So just keep that in mind. And the stuff we covered already, there's some ins and outs already that do require special extra attention, on top of what we're going to cover this week, on top of what we're going to cover next week. So this class, as you know, is a challenge no matter what. Economics is a challenging discipline, because again, we don't just talk about economics. We use tools from other disciplines, right? We use math, we use statistics to get all of our analysis as precise as possible. And so that adds layers of challenge to this course, to this discipline, that you have to acknowledge and be realistic about. And a class like this will never change for you. So regardless of what's happening in your life, the class cannot adapt to you. So you must adapt to the class. So we have certain standards we have to meet. This is a accredited university. This class is taught nationwide, as far as throughout the world. The book we use is a pretty standard book used. So there's nothing about this course that can change to make it less of a challenge for you. The only thing that can change is you. If you are not used to taking on a course like this, then you need to figure out how to do that now. The sooner the better. It's just good to be realistic about it, and I have to always be realistic about it, because you can't just paint a rosy picture about it, and then just kind of mislead people to think, oh well, things are going to work out if you just kind of casually approach the course. That's not how it works. This is technical stuff. Even though you might be getting the individual components as we move along, those individual components aren't necessarily completely related, and so they have their own sort of inner workings, logic, ultimately just all sorts of things that separate them from each other, which requires you to be able to spend enough time to get one thing, and then another one, and then another one, as we kind of cover them, and they start to mount up. So again, the approach is everything, and the time you spend is critical to how well you do in this class. So just keep that in mind. And the semester will be over at some point, and all of this will end. So that is something that you can take comfort in. But while it's happening, it is happening, folks, and you need to face it head on rather than run away from it. It's a responsibility that you have taken on for yourself. Make the best of it. Make the most of it. Conquer it. Be better than it. All right. Was there anything else I wanted to mention? Oh yes, Piazza. The deadline to sign up for Piazza is the end of this week by Sunday night, so make sure you do that. You'll lose half your communication grade if you do not do that. Um, and beyond that, all the assignments are due the middle of next week. I said the middle of third week, I meant middle of fourth week, past the time of people adding and dropping. But just get things done earlier rather than later. Again, you don't want to be doing things for the first time next week or the weekend after this one before the exam. You want to just have time to review and prepare rather than just like scurrying to catch up, etc. So make the most of all the free time you have now. All right, I'm going to jump into the material if no questions popped up as I was speaking. All right, so in chapter 2, we saw that the demand for a firm's product depends on its price. So we denoted the demand as the quantity of good X, and the D represents the quantity demanded. And that depends on its own price. So the price subscript X, again, the X denotes that it's the price of the same good we're talking about, X. We know that the demand for a goods product can also depend on the price of a related good, be it a substitute or a complement. A related good, we can just use Y to represent it, in contrast to X, the good that we are focused on. So the price of the related good Y can be denoted by PY, and then consumer incomes also affect demand of a good. We represent that by M, and then other variables you could throw in there. We just throw in H as sort of a catch-all that could represent advertising, the size of the population, or consumer expectations. So again, you have like sort of this general functional relationship between the quantity demanded of a good and the variables that affect it. So this is our dependent variable, and these are our independent variables. So that analysis of the impact of changes in prices and income on consumer demand has been qualitative rather than quantitative. A successful manager is adept at providing detailed quantitative answers to questions like, how much do we have to cut price to achieve maybe like a 3.2% growth in sales? If we cut price by 6.5%, how much more units will we sell? Do we have sufficient inventories on hand to accommodate this increase in sales? If not, do we have enough personnel to increase production? So a lot of these issues will be addressed as we move forward, both in this chapter and the subsequent ones. How much will our revenues and cash flow change as a result of this price cut? So you'll notice that, well, I'll highlight today that elasticity is closely linked to revenues and our understanding of how a price change might affect those revenues depending on how elastic demand is. So that's a relationship that's super important that you should know. But it is just sort of the tip of the iceberg with respect to the usefulness of the elasticity concept. So again, this just says the first half of the chapter we're going to focus on elasticity, and the second half we'll talk about the statistical stuff. All right, so the elasticity concept. So suppose some variables such as the price of a product increase, let's say, by 10%. So the question would be, what would happen to quantity demanded of the good? And it's going to depend on how elastic demand is, right? If it's very elastic, it'll go up by more than 10%. If it's not very elastic, it'll go up by less than 10%. So based on the analysis in Chapter 2 and the law of demand, right, as the quantity demanded goes up, well, as the price goes up, quantity demanded goes down, and vice versa. They move in opposite directions. We know that the quantity demanded would fall. We know that an increase in 10% would cause a fall in the quantity demanded, but we don't know by how much. So it would be useful for a manager to know whether the quantity demanded would fall by 5%, 10%, or some other amount. The primary tool used to determine the magnitude of such a change is elasticity analysis. So elasticity is a measure of the responsiveness of one variable to changes in another variable. It's the percent change in one variable that arises due to a given percent change in another variable. So just a very general example to highlight the fact that the elasticity concept is not specific to economics. It's not specific to demand analysis or markets. It can be used to study any relationship between a couple of variables. So for example, let's say we're thinking about the elasticity of your grade. How sensitive is the elasticity of your grade with respect to studying? So if we denote that, E denotes elasticity, G denotes the fact that we're looking at the elasticity of your grade, and then comma S, the second variable, denotes the fact that we're looking at its effect, the amount you study, on the first variable, your grade. So the elasticity of G subscript S is the percent change in your grade. So percent change in mathematics is represented by a triangle. So a percent change in your grade that will result from a given percent change in the time you spent studying. So you can just very generally establish this relationship as a ratio. Again, the percent change in your grade with respect to the percent change in studying is the elasticity of your grade with respect to studying. All right, so percent changes can be represented as the change in some variable. So in this case, the change in your grade with respect to the starting grade times 100. And the change in the studying is, again, the change in the amount you study. So remember, these are quantities. Don't get caught up in the notation. Ultimately, everything's a number, right? But when we're talking in general terms, we use notation, which if you're not used to using general notation can feel a bit intimidating, but it's just about coming to terms with it. Oh, like understanding what it is. Oh, yes, the triangle means this. We're talking about percent change in, okay, here is G. G means grade. Okay, percent change in G with respect to the original grade. In microeconomics, you guys looked at midpoint methods and like averages of starting and endpoints. We don't consider that here because we derive a different expression for elasticity from this, which you'll see in a second. So don't worry about midpoint method stuff if that's something that you remember and are trying to sort of fit into what we're talking about here. All right, so the elasticity of your grade with respect to studying can therefore be expressed as a ratio of these two expressions. The hundreds cancel out. And so we're left with the change in G over G divided by the change in S over S. What you have is a ratio divided by a ratio. If you remember from mathematics, basic property of ratios is that if you're dividing a ratio by another ratio, you can equivalently express this term as the first term times the reciprocal of the second term, the one dividing the numerator. So here we have the change in G over G times S over the change in S. So this is equivalent to this, just based on properties of ratios. And then based on the commutative property of multiplication, which means you can just move things around that you're multiplying, we can just move these terms around. And then what we wind up is we can express the elasticity of your grade with respect to the amount you study as the change in your grade with respect to the change in S. So if we have some functional relation between your grade and the amount you study, then this would be like the slope. Let's say it's a line. This would be like the slope, right? So it's like the derivative of how your grade is affected with respect to studying times the amount you study over your grade. So that's another way of just mathematically expressing an elasticity. So that's just a general sort of establishment of like the mechanics, the mathematical mechanics of the elasticity concept. Now we will move forward into applying it to things that are actually relevant to you. Just something to remember, like this term here, again, in calculus, we know that the change in G over the change in S can be approximated by the derivative or slope of a curve, which means we can arrive to this elasticity expression, which again is equivalent to this. It's just us basically saying we acknowledge that this is an estimate for a slope. And so if you remember in calculus, you can express a slope, the change in one variable with respect to another variable, as dg ds. So that's the same as this. And it's just standard notation to represent a slope. I think next class or next week I'll do a brief review of the derivative, just so that you remember some of the ins and outs of it, so you can at least take derivatives, because you will be expected to take derivatives. All right, so two aspects of an elasticity are important. One, whether it's positive or negative. So the sign of the elasticity determines the relationship between G and S, right? So if it's positive, in this case, that means extra studying increases your grade. If it's negative, it means that extra studying decreases your grade. That's what I just said. Two, whether it is greater than 1 or less than 1 in absolute value. And we're talking about absolute value. We're talking about the distance of a number from 0 on a number line, right? So -5 has an absolute value of 5, -20 has an absolute value of 20, 30 has an absolute value of 30, right? Distance from 0 in the number line. So whether or not it's between 0 and 1 or greater than 1 in absolute value is of importance when we're looking at the elasticity concept. So whether the absolute value of the elasticity is greater or less than 1 determines how responsive G is to S, how responsive your grade is to the amount you study. If the absolute value of the elasticity is greater than 1, we know that a small percent change in studying will lead to a relatively large percent change in your grade. If the absolute value of the elasticity is less than 1, a given percent change in studying will lead to a relatively small percent change in G. All right, now let's move on to actually applying this to something of relevance here, which is the own price elasticity of demand. How sensitive is quantity demanded to changes in price in a particular market? All right, so the own price elasticity of demand is a measure of the responsiveness of the quantity demanded of a good to a change in the price of that good. Again, it's the percent change in quantity demanded divided by the percent change in the price of the good. So for demand function, again, is the relationship between quantity demanded and price. So quantity demanded as a function of price. And if we're looking at the other variables, we can throw those in as well. For the general form, the own price elasticity of demand is going to be denoted, the elasticity, again, of the variable we're interested in looking at, which is the quantity variable with respect to changes in the price variable. So the percent change in the quantity demanded of X divided by the percent change in the price of X. We know that this is equivalent to the change in the quantity demanded of X over the change in the price of X. So the slope of the demand function times the price and the quantity demanded over the quantity demanded, which is equivalent to dq dp, the slope of the demand curve with respect to price, times the price over the quantity. So if the own price elasticity of demand for a product, let's say, is -2, we know that a 10% increase in the price, in the product's price, will lead to a 20% decrease in the quantity demanded of the good, since -20% over 10%, -20% being the change in quantity demanded, -10% being the change in price, equals -2. By the law of demand, as we know, there's an inverse relationship between these variables, and so this will always be negative. The own price elasticity of demand will always be a negative number. As far as like the magnitude, we can describe the magnitude in different ways depending on, again, whether it's in absolute value between 0 and 1 or greater than that, or actually being just 1. So if the elasticity is greater than 1, we say demand is elastic. If the elasticity is less than 1 in absolute value, so it's between 0 and 1 in absolute value, so it can be negative, 0.3, or it can be 0.3, whatever. As long as it's in absolute value, the distance from the number line less than 1, then we say demand is inelastic. And demand is said to be unitary elastic if the absolute value of the own price elasticity is equal to 1. And this will actually turn out to be a really important elasticity, and I'll mention why towards the end of today's lecture. All right, so elasticity and total revenue have a very important relationship, which can be highlighted by the table here. Here we've got the price of the software, the quantity of the software sold, the own price elasticity of demand along the demand relationship, the demand schedule that is changing, and then total revenue that corresponds to each price quantity elasticity point. So notice that the absolute value of the own price elasticity gets larger as price increases. So in absolute value, the own price elasticity of demand gets larger, right? So we go from inelastic demand to unit elastic demand to elastic demand. So the reason for this can be sort of examined from the expression we derive for the elasticity. So the slope of this linear demand curve, so we're told this is the function for this demand curve. So this is a demand function, quantity as a function of price equals 80 minus 2p. We know the slope of the function is constant at -2. It's not changing. So we know that that component of our elasticity is -2. And that implies that if we're looking at this expression, that this is not going to change. It's going to stay constant at -2. So it implies that the elasticity, the own price elasticity of demand, will increase in absolute value as the price of X increases. So as the price of X goes up, then the elasticity will go up as well. This will remain constant. So here we see that playing out as the price increases, we see the own price elasticity of demand increasing. So demand gets more elastic as price increases, becomes more sensitive to changes in price. Quantity demanded responds in greater proportion to changes in price. So thus, the own price elasticity of demand varies along a linear demand curve. So that's important to understand. When the absolute value of the own price elasticity of demand is less than 1, so here's it being equal to 1. So when it's less than 1 in absolute value, an increase in price will increase total revenue. So if we are at low price points here, all the way up until line E, where the own price elasticity of demand is unitary elastic or unit elastic, as the price is increased there and demand is inelastic, we see that revenues increase as the price increases. When the absolute value of the own price elasticity is greater than 1, an increase in price leads to a reduction in total revenue. So beyond that point of unitary elasticity, as you increase the price, because demand is elastic, greater than 1 in absolute value, beyond a price of $20 per unit, we see that as price increases, total revenues start to actually decrease over that range. And total revenue is maximized at point E, where the own price elasticity of demand is equal to 1, where demand is unitary elastic. So the unitary elasticity point is the point that corresponds to the maximum revenues that can be earned in a market. So this relationship among the changes in price, elasticity, and total revenue is called the total revenue test. So if demand is elastic, an increase in price will lead to a decrease in total revenue, and vice versa. So here we are. Here's a demand curve downward sloping. Here we have prices being pretty high, 10, 9, 8, 7, 6. So over that range, demand is elastic over the high range of prices and low quantity demanded. Down here we have our total revenue. So total revenue is a function of quantity. So quantity is the X variable in both of these graphs. And then price is the dependent variable up here, and total revenue is a dependent variable up here. Again, so let's say we're at 4 units, and you want to increase the price. So in order to increase the price, in order to increase the price, you have to lower the quantity that you're going to sell, right? So people aren't going to buy as many at $4 as they are at $9. So as you are increasing your price, we see as we're moving from left to right here that total revenues decrease. Just again reflecting that same relationship we saw on the table. Yeah. So decrease is like the opposite case. So demand is elastic. A decrease in price will lead to an increase in total revenues. What the parentheses mean there? Yeah, just like the opposite. All right. So yeah. So over the high price range where demand is elastic, let's say we're looking at it the other way around. If we're decreasing price, then you're going to increase total revenue. If demand is inelastic, So over this range here, if demand is inelastic, an increase in price will lead to an increase in total revenue, and a decrease in price will lead to a decrease in total revenue. So let's say we're at this point here that corresponds to 5 units, and we are increasing quantity, therefore, and lowering price. Lowering the price here will decrease total revenue, right? So a decrease in price will lead to a decrease in total revenue. That's what we're seeing over the inelastic range of demand. And then finally, total revenue is at its maximum at the point of unit elasticity. So, you're going to have a range where demand is elastic. You're going to have a range where demand is inelastic. So there has to be a point where that transition happens, right? Where you go from elastic demand to inelastic demand, and that's the point of unitary elasticity, where elasticity equals exactly 1. That is the point where revenues are at their maximum. And so these green bars, if you just kind of draw a line through them, will represent the total revenue curve that increases and decreases. And this whole slide and the last table highlights again the relationship between total revenue, elasticity, and price changes, which is embodied in the total revenue test. So businesses around the globe use the total revenue test to help manage cash flows. Dell recently faced a dilemma regarding its pricing strategy for computers. Should it increase prices to boost cash flow or adopt a cut price and make it up in volume strategy? So based on a careful analysis of its demand, the company decided to adopt the latter strategy and reduce prices in order to increase revenues. To see why, suppose the research department of a computer company estimates that the own price elasticity for a particular desktop computer is negative 0.7. So negative 0.7 is what kind of elasticity? Did I say 1.7? Okay, I meant 1.7, sorry. Negative 1.7 is elastic demand, exactly. So if a company cuts price by 5%, so you're at the elastic range, right? You're cutting price. Based on our total revenue test, is that going to increase revenue or decrease revenue? Increase revenue, right? You're going to lower your price, you're going to move down the demand curve, and then that's going to increase your total revenue because you're looking at elastic demand. It's good to kind of just visualize that graph we just saw to kind of understand this relationship. So again, here, if the company cuts prices by 5%, the question is, will computer sales increase enough to increase overall revenues? So we can answer the question by setting our own price elasticity expression equal to the amount we're given, which is negative 1.7. And the percent change in price is negative 5. So plugging that in, we can figure out what the percent change in quantity demanded will be. So now it's just algebra, right? We're solving for this amount here, so we can multiply both sides by negative 5. And then that solves for the percent change in quantity demanded, which is 8.5%, right? Price goes down by 5%. That means the quantity demanded will go up by 8.5%, yeah.
So we stick to just using the number 5 rather than 0.05%?
As long as you're consistent, it doesn't really matter. So it's up to you. It's up to you to just be consistent and then know what the value ultimately is, either in decimal form or in percentage form. Yeah. You can jump back and forth as long as you know what you're doing and can like read properly your result. All right, so the quantity of computers sold will rise by 8.5% if prices are reduced by 5%. Since the percent increase in quantity demanded is greater than the percent decline in prices, the price cut will actually raise the firm's sales revenues. All right, so that's the total revenue test. Super important, powerful. We'll cover it again in different times throughout the course, but certainly understand it. And I'll mention it again, I think, in a bit also. All right, so beyond the fact that there are varying elasticities along a demand curve, the overall demand for a market can also be elastic or inelastic, and that is represented by the steepness of the demand curve. So if the demand curve is super flat, the extreme case being completely flat, you have perfectly elastic demand. Demand is as sensitive as it can be to changes in price. And that means that a small change in price, so a small increase in price, will cause quantity demanded to go down to zero immediately. And a small decrease in price will cause quantity demand to increase infinitely. So producers of generic, unbranded products such as aspirin may face a demand curve that is perfectly elastic. So if the good that's being sold in your market is something that anybody can sell, and therefore there's a ton of substitutes available for your one thing that you're selling, like a generic brand aspirin, then again, you change your price by even the slightest amount, nobody's going to buy it from you because they can just buy it from the alternatives for slightly lower prices. So demand in that case will be perfectly elastic. A small increase in price may induce their customers to stop buying their product in favor of a competing generic version. The other extreme end of the elastic demand spectrum is a perfectly inelastic demand, which can be represented by the vertical demand curve. So in contrast, when demand is perfectly inelastic, consumers do not respond at all to changes in price. So like life-saving medicine, right? Like things that people need to survive. People have like a disease that only one, medicine can help them sort of at least survive through. They are willing to pay anything for that. So, a firm can theoretically raise their price as much as possible, and quantity demanded will not change because demand is perfectly inelastic. So many perceive products and services in the healthcare industry, such as life-saving drugs, that have demand curves that are perfectly inelastic. But of course, most cases will be somewhere in between. So what ultimately is important to know is like the steeper demand gets, right? The more vertical it gets, the more inelastic demand gets, and the flatter it gets, the more elastic demand gets. One simple sort of mnemonic way of remembering it is like just perfectly inelastic demand curve is vertical, which kind of looks like an I, which is the first letter of inelastic. All right, factors affecting the own price elasticity of demand. So what affects like how sensitive consumers are in a market to changes in price? Well, there's three main factors that affect the magnitude of the own price elasticity of a good. The first is the availability of substitutes. How many other things can people buy that are similar to the thing that's being sold that has a price changing? So one key determinant of the elasticity of demand for a good is the number of close substitutes for that good. A key implication of the effect of the number of close substitutes on the elasticity of demand is that the demand for a broadly defined commodity tends to be more inelastic than the demand for specific commodities. So here you see like transportation, the own price elasticity of demand just in that very broad category of transportation is inelastic. It is 0.6. But a form of transportation, motor vehicles, has elastic demand. It's negative 1.4. Motorcycles and bicycles, even more, negative 2.3. Also food, the general category of food, in general, very inelastic, right? People aren't going to respond much to changes in price because food is what we need to survive. But depending on the type of food and the prices that you find in each individual product, you will find more elastic demand in those individual subcategories, more specifically defined versions of that commodity food, such as cereal. In this case, negative 1.5, representing that cereal itself is more elastic than food in general, which is inelastic. So market studies support the statement that demand is more elastic when there are more close substitutes for a product. Time is the second main factor that affects how elastic demand is in a particular market. How much time do people have to find substitutes? So demand tends to be more inelastic in the short term than in the long term. In the long term, people have time to search out alternatives to whatever it is they're buying. So the more time consumers have to react to a price change, the more elastic the demand for the good. So here is transportation. We see the short-term own price elasticity is negative 0.6, but long-term own price elasticity is negative 1.9. So let's say people live a certain distance from their job, and initially prices are changing in gas or fares for the bus or whatever. they need to get to work. They're going to pay. But in the long run, they might move, right? They might move closer to their job to save money, right? So in the long run, demand will be more elastic for transportation than in the short run. And the third main factor that affects the own price elasticity of demand is the expenditure share. How big of a part of one's budget is the thing that's being purchased? So goods that comprise a relatively small share of a consumer's budget tend to be more inelastic than goods for which consumers spend a sizable portion of their income. So, salt is a small part of everybody's income, if any at all. If the price doubles of salt, you're going to keep buying salt. I mean, whatever. It's cheap to begin with. Even if it doubles, you're still going to buy salt. Whatever. If your apartment doubles in price, which makes up a huge part, or your housing or whatever it is, your mortgage, whatever, doubles in price, you're immediately going to respond to that, right? You're not just going to sit back and just like, okay, fine, I'll take out a loan to pay for my loan. You're not going to do that. You're going to respond to that. You're going to figure it out. You're going to get out of that apartment or whatever. Like, your demand is very elastic for something that makes up a large portion of your budget expenditure versus something that makes up a small portion. So the average U.S. consumer spends almost 4 times as much on food as on transportation. So food will tend to be more elastic than transportation, as we see here. Small differential in the short run, larger in the long run. All right, let's talk about the concept of marginal revenue and the own price elasticity of demand. So we talked about marginal benefit and marginal cost in chapter 1, a very general approach to studying how much questions. How much should I purchase? How much should I produce? Well, let me look at the extra benefit from purchasing one more unit and the extra cost of purchasing one more unit. Let me look at the extra benefit of producing one more unit and the extra cost of producing one more unit. The extra benefit of selling one more unit is what we call the marginal revenue. So the marginal benefit of selling is the marginal revenue. It's the extra revenue you gain from selling one additional unit. So we learned in chapter 1 that marginal revenue is the change in total revenue due to a change in output. So to maximize profits, a firm should produce where marginal revenue equals marginal cost. In this case, we have our downward sloping demand curve, and this is the marginal revenue curve that corresponds to that demand curve. And I'll talk about why it is below the demand curve in a second. So the line labeled MR is the marginal revenue associated with each price output pair on the demand curve. So notice that for a linear demand curve, the marginal revenue schedule lies exactly halfway between the demand curve and the vertical axis. So our intercept for our demand curve is 6 on the horizontal axis, the x-intercept. And the intercept for our marginal revenue curve is exactly half of that. It's 3. Furthermore, marginal revenue is less than price for each unit sold. So when you have a downward sloping demand curve like you do here, the marginal revenue will be less than the price for each unit sold. So each additional unit sold won't generate the extra revenue that is reflected in the price. The marginal revenue, the extra revenue gained from selling additional units, will be less than that price when you have a downward sloping demand curve. So to induce consumers to purchase more of a good, a firm must lower its price. When the firm charges the same price for each unit sold, this lower price is received not only by the last unit sold, but also on those units that could have been sold at a higher price had the firm not lowered its price. So at any given point, you're selling a certain amount of goods, and then you want to sell more, so you have to lower the price. But you can't just lower the price on that next unit. You have to lower the price on all the units you're selling. To be concrete, suppose consumers purchase 1 unit of output at, say, a price of $5 per unit. So you have 1 unit of output sold at $5. This generates total revenue of price times quantity is revenue. So price is $5. You're selling 1 unit, so your total revenue is $5. Consumers will purchase an additional unit of the good only if the price falls, say, from $5 to $4. So if the price falls to $4, then 2 units will be sold. So now the first unit will, once again, the first unit that was selling at $5 will now need to be sold for $4. And the second unit will also, of course, be sold for $4. So the total revenue will be 2 units times $4, which is equal to $8. So that will be the revenue there. So the firm loses $1 in revenue from that first unit that was selling at $5 and now is selling at $4, right? So there's that loss in revenue from increasing the output, but there's also an increase in revenue by gaining the price of that new unit sold. So the firm loses $1 in revenue because the first unit now brings $4 instead of $5. Notice that by decreasing price from $5 to $4, quantity demanded increased from 1 unit to 2 units, and total revenues increased from $5 to $8. By the total revenue test, this means that demand is elastic over this range. So price has been decreased, total revenues have increased. Total revenue test tells us that demand is elastic over that range. So it's happened along this range here. In contrast, had the price reduction increased quantity demanded but decreased total revenues, demand would be inelastic over the range and marginal revenue would be negative. So the inelastic range is going to occur beyond the point where marginal revenue is equal to 0. So along this range here, along the elastic range of demand, marginal revenue was less than the price. So here, again, going from 1 unit to 2 units, total revenue went from 5 units to 8 units. That means that the extra revenue gain from selling that second unit, the marginal revenue, was $3. It was less than the price, $4, but still positive because demand is elastic. But when demand becomes inelastic, then that's when marginal revenue starts to become negative, which again corresponds to a lowering of total revenues as you decrease price. So at the point where, again, we switch from elasticity to inelastic demand along the demand curve, which again is a point of unitary elasticity, where elasticity is equal to 1, that corresponds to the point where marginal revenue is equal to 0. So when elasticity is unitary, marginal revenue is equal to 0. In fact, the more inelastic the demand for a product, the greater the decline in revenue that results from a price cut despite the increased quantity demanded. So marginal revenue gets less and less as we increase demand more and more. So this intuition leads to the following general relation between marginal revenue and the elasticity of demand. So we can establish the relationship as this, where marginal revenue equals price times 1 plus the elasticity over the elasticity. I want to show you how to derive that relationship because the math is a little bit more complicated than we're comfortable with at this point. Just understand that this relationship does embody what we just saw on the graphs, which again correlates to the total revenue test. And this will actually turn out to be a really powerful relationship towards the end of the course when we start talking about like practical means of identifying how to maximize a market without having maybe all the sophisticated tools that you would need that are implied by the middle of the course when we're talking about production and understanding your costs and demand. If you're a small firm and you don't have information about like costs and demand in the way that you would in a large firm that could hire an economic analyst, like this relationship here will actually help you to estimate how to best choose your output and price quantity under those circumstances. But it's something we'll talk about later in the course. Yeah. Goods and services are embodied in these kind of markets. So you could be selling services as well. Yeah. But sometimes it depends on what the service is. Like you have to look at markets individually to see if the general principles that are established here apply to every single market. Sometimes they apply slightly differently depending on the market characteristics. But in general, most goods, especially commodities, which are general like oil, wheat, the big sort of things that are bought and sold in sort of in generic types, like this, all of this applies to those markets. Anyway, this relationship between marginal revenue and price. Let's look at a couple of examples. So notice that when the demand is inelastic, meaning it's elastic. So it's less than -1 and greater than negative infinity. So in absolute value, it's greater than 1. We know demand is elastic, and the formula implies that marginal revenue is positive. So let's say we have an elasticity that is -1.8, which again represents elastic demand because it's greater than 1 in absolute value. Plugging it into this formula here, you've got a negative number in the bottom. You've got 1 plus a negative number that's larger than it. So this will be negative as well. Negative divided by negative is a positive. And so then we know marginal revenue will be positive when demand is elastic, which means that total revenues are increasing. Extra revenues sold generated by selling an additional unit is positive. You're increasing total revenue. When elasticity is equal to -1, demand is unitary elastic. Plugging that into our relationship here, you have 1 plus -1, which is equal to 0, right? So this whole expression will then be equal to 0. So that means when demand is unit elastic, marginal revenue is equal to 0, which corresponds to that point on our graph where, again, elasticity was equal to -1, unit elastic, which corresponded to the point where total revenues were at their maximum, right? So just remember from calculus, whenever you're maximizing a curve, you want to set the derivative equal to 0. Marginal revenue is the derivative of total revenue. And so when total revenues are maximized, the marginal revenue will be equal to 0, which is what this is telling us, which is what that graph told us. At that point of elasticity being unitary elastic, marginal revenue hit the x-axis, meaning that it was equal to 0 at that point. When elasticity is between 0 and 1 in absolute value, demand is inelastic and marginal revenue is negative. So we throw in, say, let's say -0.8 into this expression here. So you've got a negative number down here. You got 1 plus -0.8, so that's going to be positive. A positive divided by negative will be negative. So therefore, this expression will be negative. So marginal revenue will be negative when our elasticity is negative. Again, corresponding to the fact that an additional unit sold will lower total revenue. Marginal revenue is negative along the inelastic range of demand. All right, let's talk about the cross-price elasticity of demand. How sensitive is quantity demanded of one good to changes in the price of a related good? So the cross-price elasticity is a measure of the responsiveness of the demand for a good to changes in the price of a related good. It's the percent change in the quantity demanded of one good divided by the percent change in the price of a related good. This elasticity helps managers ascertain how much its demand will rise or fall due to a change in the price of another firm's product. So just generally, again, you've got the X's and Y's you have to keep track of to remember that X corresponds to the good that we're thinking about, the market that you might be operating in, versus Y, which corresponds to a good that's related to X, but not X, right? So this is the price of a related good. They could be substitutes, they could be complements. It depends on the sign of the elasticity, which we'll talk about in a second. So whenever X and Y are substitutes, an increase in the price of Y will lead to an increase in the demand for X, right? So going back to what we talked about last week, Coke and Pepsi, if the price of Pepsi goes up, people substitute away from it to Coke, right? They're pretty much the same thing in most people's eyes. And so they are considered substitutes, and thus the percent change in price in one good will lead to a positive percent change in the quantity demanded of the other good for substitutes. So our cross-price elasticity of demand will be positive whenever goods X and Y are substitutes. Whenever goods X and Y are complements, though, again, they're bought together, like peanut butter and jelly in the US are bought together. So if the price of peanut butter goes up, people buy less peanut butter, but they also buy less jelly, right? So when goods X and Y are complements, an increase in the price of, let's say, Y. Let's say X is peanut butter and Y is jelly. An increase in the price of jelly, Y, leads to a decrease in the demand for X, peanut butter. So therefore, the cross-price elasticity of demand will be negative for complements. All right, so clothing and food have a cross-price elasticity of negative 1.8. So negative 0.18, sorry. And so obviously demand is cross price elasticity of demand is inelastic because again it's between 0 and 1 in absolute value, but it's also negative, right? So that means they are what? They're complements, right? They're complements. As the price of food goes up, the quantity demanded of clothing goes down. You can think of it as like when people like go out to dinner. I think that's probably what it's referring to is like food going out. Like to go out, you have to dress up, so they kind of go together. So this means that if the price of food increases by 10%, the demand for clothing will decrease by 1.8%. Food and clothing are complements. Cross-price elasticities play an important role in the pricing decisions of firms that sell multiple products, so firms that sell more than one type of good or service. Many fast food restaurants offer hamburgers for sale under $1 because their managers realize that hamburgers and sodas are complements. Thus, by lowering the price of burgers, a restaurant affects its revenues for both burgers and sodas because they are bought together. So the precise impact on these revenues depends on the own price elasticity of demand and the cross-price elasticities of demand. Generally, suppose a firm's revenues are derived from the sale of two products, X and Y. We can continue thinking about X as hamburgers and Y as sodas. Then the overall revenues to the firm will be equal to the revenue they gain from selling good X, hamburgers, and plus the revenue they gain from selling the second good, sodas, Y. So the impact of a small percent change in the price of product X on total revenues of the firm is equal to this expression here that you have to memorize. I'm just kidding. You will not have to memorize this. I will not expect you to memorize this. This is just to highlight the usefulness of these concepts and how it can help a firm that sells multiple products. But I will not expect you to memorize this equation. So just keep that in mind. Anyway, so the change in revenue will be equal to, so this is the revenue of good X. This is the revenue you gain from selling hamburgers. We're thinking of a small percent change in the price of hamburgers, let's say, and how that's going to affect total revenues, which again are related because there's a cross-price elasticity of demand that highlights the fact that hamburgers and sodas are sold together. The goods are complements. So here we've got 1 plus the own price elasticity of demand times the revenue of X plus the cross price elasticity of demand times the revenue you gain from Y. So this one is actually the cross price elasticity of demand. So this reflects the demand of good Y, how that's being affected by the change in the price of X. So the demand of sodas with respect to changes in the price of hamburgers times the revenue you gain from selling sodas times the percent change in the price of X, which is what's causing the change in your overall revenues, that you're changing the price of hamburgers, let's say. So suppose a restaurant earns, let's say, $4,000 per week in revenues from hamburger sales, product X, and $2,000 per week from soda sales. So the revenue from hamburgers, $4,000, revenue from sodas, $2,000. If the own price elasticity of demand is equal to negative 1.5, right? So how do we characterize that kind of elasticity? It's elastic demand. It's elastic demand. And the cross-price elasticity of demand between sodas and hamburgers is equal to negative 0.4. So what is that negative 0.4 telling us about these two products? They're complements. If they're negative, they're complements, right? The price of one goes up, the quantity demanded, the other goes down, right? And also the demand is what? The cross-price elasticity of demand it's elastic as well. That's two pieces of information that we can glean from this number. So the question is, what would happen to the firm's total revenue if it reduced the price of hamburgers by 1%? So we can say that the change in the percent change in price is equal to negative 0.01. So plugging all this stuff into our formula, if I were to give you a problem like this, I would give you the formula, and then you'd have to kind of figure out what the components are based on the problem. All right, so we know our revenue is 4,000 from selling hamburgers. We know the own price elasticity of demand is equal to negative 1.5. So 1 minus negative 1.5 plus the revenue from sodas is 2,000 times the cross price elasticity of demand of sodas with respect to hamburgers, which is here. So that's equal to negative 4 plus the percent change in price, which is equal to negative 0.1. Yeah. Uh, based on the price of the burger. Remember, so price of X, quantity of X. So you know that that's the own price elasticity by just looking at those subscripts because they're the same. So we're talking about the same good and the same its own price. Versus here, we're talking about the quantity of Y and the price of X. So that's how you can identify what one elasticity is from another. You got it? All right. So now order of operations. Please excuse my dear Aunt Sally. Right? Parentheses first. So that's going to be negative 0.5. 2,000 times negative 4 is going to equal negative 8,000 there. Multiply these two, which is equal to negative 2,000 minus 8,000. So that's equal to negative 10,000 times a 0.01, which equals $100. So changing the price of sodas by 1% will, lowering the price of sodas by 1% will increase total revenues by $100 for this fast food joint, whatever. Powerful relationship, powerful expression that it can be very useful, for a small business or even a larger one that does, large sales and lots of markets. And finally, let's look at the income elasticity, the third type of elasticity we'll look at before we jump into the quantitative demand analysis and using statistics to study demand. And then we can see how we can actually, just from data from a market, get to demand relationships and also extract these elasticities that we're talking about here from just doing basic statistical analysis that you can do on a spreadsheet on Excel, which I won't show you how to actually do it. I'll just mention it. You may have done it in a class before, but when I mention it, I'll highlight the simplicity of it and how you could just do a quick sort of Google search on how to do it yourself on Excel. Anyway, let's look at this third elasticity, the income elasticity, a measure of the responsiveness of the demand of a good to changes in the consumer income. The percent change in quantity demanded divided by the percent change in income. So quantity demanded of good X with respect to the change in income. M is the variable we've been using for income. When good X is a normal good, an increase in the income leads to an increase in the consumption of X. So what does that tell us about the income elasticity of demand? What sign is that going to have? Positive, right? It'll be a positive, right? So when our income elasticity of demand is greater than 0, we know X is a normal good. So again, you can use statistical analysis to identify the relationship between two variables, either by looking at the own price elasticity of demand or just looking at the coefficient on the income variable that's affecting your demand variable, depending on what form you have it in. We'll talk about that next time. When X is an inferior good, so incomes go up, people buy less of it. Like I mentioned, generic brand hot dogs, just crappy frozen meals, things that people buy less of when they make more money. Those are inferior goods. It can be anything. It can be whatever you buy less of. Whatever you consider an inferior good is an inferior good. There isn't a blanket sort of rule about what those are. Very subjective term. But when X is an inferior good, but you can do an analysis of a market and figure out, when incomes are changing in this market, how is that affecting, a quantity demanded of my good? Is my good considered a normal good or an inferior good by this population versus whomever I'm interested in selling to? So, it's very powerful and it can have a lot of important implications on, profitability. So when X is an inferior good, an increase in income leads to a decrease in the consumption of X. Therefore, the income elasticity of demand will be less than 0, will be negative when X is an inferior good. So table 3.5 presents some classic estimates of income elasticities for various products. We see that transportation is considered a what kind of good? A normal good. It's positive. Food, normal. Ground beef, non-fed, so just crappy meat is inferior. So the income elasticity for transportation gives us two important pieces of information about the relationship between income and the demand for transportation. Again, as we know, since it's positive, we know that consumers increase the amount they spend on transportation when incomes rise. So it is a normal good, as we mentioned. Second, since the income elasticity for transportation is greater than 1, we know that expenditures on transportation grow more rapidly than income does. As income goes up, people tend to spend a greater proportion on transportation, right? Like maybe buy cars versus, go on buses, like that kind of thing. You have an increased amount proportionally of spending on transportation as you have a smaller proportion of increase in incomes, because transportation is highly income elastic. The second row of the table reveals that food also is a normal good, since the income elasticity is 0.8. Since the income elasticity is less than 1, an increase in income will increase the expenditure on food by a lower percentage than the percent increase in income. So, obviously people buy food. Food is a priority for all of us. We buy the things we need generally, regardless of how much money we're making. We're going to buy the things we need. So as our incomes go up, yeah, we might buy slightly better quality meats, we might buy slightly better quality vegetables, etc. But it's not going to go up by that much relative to the income increase. So when incomes decline, expenditures on food decrease less rapidly than income. That's the other way to look at it, the opposite direction. All right, folks, we're done covering the stuff from today. Hope you have a good couple of days. I'll see you on Thursday. We'll finish off this chapter. Keep in mind everything I said at the beginning. Every moment is an opportunity to get ahead. Every moment is to start preparing so that, you have a really successful semester. Anyway, I'll see you on Thursday.